Okay, let's try and solve this numerically. What we need to do is an equation relating the number of particles at one time to the number of particles a short time, delta t, later. So we've got n particles at the beginning of the time, which should go to n plus delta n. And what we're going to want is an equation relating delta n to delta t. So how many particles change, decay, as a function of the time step. And as usual, we're going to assume that the decay rate is constant over this interval delta t. The decay rate is, of course, really changing all the time. But once again, if you make delta t small enough, it's going to be approximately constant, and that's how numerical solutions always work. So what's the change in the number of particles in some time? Well, it's going to be a negative value. The number of particles is going to go down as they decay. How many are going to decay? Well, that's going to depend on the number of particles they are times the probability of each one decaying. So if you have 1 million particles and there's a 1 in 100 chance, then it's going to be 1 million times 1 over 100, so that's 10,000 particles are going to decay in that second. But what if our time step isn't a second? If you had 100,000 particles decaying per second and your time step is only a tenth of a second, you're going to get 1/10 as many particles decaying. So what we really need to do is multiply by delta t here. The shorter the time step, the fewer particles are going to decay. So that's the equation we're going to need to solve numerically.